This video is sponsored by PCBWay. Welcome everyone. In this video I continue to work with the TCD1304 linear CCD. This project is also a revision of an older 4 years old project. It is a miniature breakout PCB for the TCD1304 linear CCD. It allows you to directly plug the board into a STM32 F401 CCU6 microcontroller board. The board has the usual curved traces, and due to the purpose of the board, I purchased it in matte black color to avoid reflections and such. The PCB is marked with the purpose of the board and my signature, including the year of the release. The two little arrows show the mounting direction, and this side of the PCB should face the USB port of the microcontroller board. The top side of the PCB is very simple. It has 4 rows of pins, 2 for the microcontroller and 2 for the CCD. It also has 2 M2.5 mounting holes. As you might have noticed, the board has sharp rectangular corners instead of rounded edges as I usually design them, but this is intentional. When it is compared to the previous video's board, you can see that it is basically the same design. At the first glance, the only difference is the additional rows of holes for mounting the CCD board on the microcontroller board. However, if you look closer, you can notice some slight changes to the layout of the signal conditional circuit. This is due to the fact that I had to reach certain pins on the microcontroller and they were across the other side of the PCB as compared to the 6-pin connector. The original board is a bit larger, bulkier one as you can see it. It is much wider due to the placement of the holes, but the basic idea is the same. When I flip the device, you can see that the top of the microcontroller faces downwards. I realized that this makes no sense and makes the circuit larger. So in the current version of the board, as you will see it soon, the microcontroller is flipped and it blends in smoothly. With this modification, the USB connector will be placed neater. Also, if we look at the bottom side, the component side, we can see that the old board has more bulkier passives. These are 0805 components and they are replaced with 0603 ones in the current version. It saves some space, but they don't have other effect on the circuit. They are exactly the same values. Also, I figured that it is better to put the female header on the microcontroller board and the male header on the TCD1304 board. This is just a matter of taste probably, it doesn't have any effects. If you want to get this or the other board manufactured or even assembled for your project, visit PCBWay's website and my project page and place an order. Or if you have your own boards, please consider using their services. Apart from PCB manufacturing and assembly, they also have 3D printing, CNC machining and similar services, so you can use them for any types of projects. Check the link in the description and visit their website. So you might think why I make 2 similar boards. Well, if you look at the miniature PCB, you can see that it is connected to the microcontroller with a bunch of wires. This is useful when you want to save space, or if you want to move the PCB for some reason. Then the driver board and the microcontroller board can be separate. And in the case of this board, the 2 boards can stay together. So these are the components that I'm going to use in this project. I just want to mention a few things which could be useful if you are planning to replicate this project. To mount the CCD on the PCB, I use Presi-dip connectors. I don't want to solder the CCD for several reasons. First of all, it is a sensitive device and I don't want to damage it by soldering it. But also, if the device is damaged for some reason, it is much easier to replace it if it is only mechanically connected, i.e. plugged in into the socket. And as I mentioned earlier, the CCD carrier board will receive the male pin headers and the microcontroller board will receive the female headers. But this is just a matter of taste. I don't think it really matters. So with all this explanation, let's assemble a board. So the board is done. As I mentioned previously, one of the drawbacks of these boards is that they attract the dirt, so they can look ugly under certain light conditions after a failed attempt of cleaning. I tried to wipe it with some flux cleaner and ethanol, but I was not patient enough and smeared the dirt all over the board. If you get a matte black board, prepare for this issue and be patient when cleaning it. When looking at the boards side by side, it makes more sense to see the purpose of the two tiny arrows. They help us to see how the two boards are plugged into each other. Looking at the current iteration of the board and the previous one, it is more obvious that this board is much more streamlined and it looks better. There's definitely some height saved by flipping the microcontroller, but more importantly, there are less exposed pins facing the outside of the device. The narrower board is also more obvious thanks to the fact that I replaced the mounting holes and shaved off from the width of the board. Since the CCD is still missing from the new board, let me mount it. And it is a bit tedious task because all the pins are misaligned to some extent, but with some patience, it can be done. Once the CCD is mounted, let me show you the two boards side by side one more time so you can see the improvements and changes. The CCD side is basically unaffected in terms of height, but the overall height of the board became smaller by the height of the USB-C port. And the width is also narrower thanks to the holes I removed and replaced. Now it's time to test if the board works as expected. I use my own firmware that I developed in STM32 Cube IDE, and I also use my own PC software that I developed in Microsoft Visual Studio. I just simply plug the board in and then I connect to the corresponding COM port in my software. I pre-programmed many shutter speeds and I need to select one of the shortest one because the CCD is facing my desk light and my monitor, so there's a lot of light. As you can see, the CCD reacts to the blocked light as expected. However, due to the way the light falls on the CCD, the signal does not look exactly as it should because the two sides of my finger blocks out the light differently. If I cover the light coming from the monitor with my other hand, the signal becomes a bit better. If I place a male pin header on the surface of the CCD, the periodic structure of the shadows of the pins show up very nicely. If I totally block the light, then the signal becomes flat, but at a lower level. You might notice that the zero light still produces a relatively high signal. I've been playing around with different resistor values for the op-amp to introduce different gain and offset values, and this is the result of it. Not ideal, but this is just a test. This is not the final values of the components. What matters is that the new circuit works and it behaves as expected. I will, however, keep the previous configuration of the resistors because it utilizes the range of the ADC better. If you are interested in this circuit, contact me via my website. I'm planning to sell them directly in the near future. Visit my website, I put a link in the description. Also, if you want to see more of these developments, please consider supporting me by becoming a channel member. It allows me to focus more on these gadgets. Finally, don't forget to visit PCBWay's website if you want to get these or your own gadgets manufactured. I hope this video was useful to you, I hope you learned something, and see you in the next video.